Hello grade 11s. We're going to move on to triangles today in analytical geometry. But before we do an example, there's just some facts we need to remember from previous years. The first thing is the word median. And a median is a line that goes from a vertex of a triangle to the midpoint of the other side. So the median is actually the line from the vertex to the midpoint of the other side. So another median in this triangle would be the green line, which goes from the vertex to the midpoint of the other side. Then we move on to altitude. And altitude is from the vertex and perpendicular to the opposite side. So that line there would be an altitude. And then thirdly, your perpendicular bisector is a line that is going to bisect a line, segment in this case AB, but bisect it at 90 degrees perpendicularly. Now we move on to a worked example where we combine all of our knowledge of analytical geometry, distance, finding formulas of straight line, finding points of intersection, gradients, etc., etc. So this is a very nice worked example. So let's have a look. The following sketch shows triangle ABC with median AM. Remember, median cuts the opposite side in half, so that means that BM would be equal to MC, and M would be the midpoint of BC. And then we also have altitude AP. So that line there is an altitude which would cut at 90 degrees. So AP would be perpendicular to BM. Then we need to find the equation of median AM. So we need to go and find the equation of this line AM. So remember, the equation of a straight line is y equals mx plus c. So we essentially need to find the gradient and then another point which lies on the line. So now I can find the gradient of AM because I can work out the point M because it's a midpoint. Then once I've got point M, I can find the gradient because I have change in y over change in x. And then I've got a random point which I could sub in place of x and place of y, and I can solve for c. And then they go ahead and do it. There's your midpoint. Then once you've got the midpoint, you've got the gradient. And then we don't like to use that one. We like to use y equals mx plus c, where we're going to sub in the point. We're going to either sub in A or M. So let's sub in A, which is going to be 2, 3. So that means my y is going to be 3. My M we've worked out to be 7. My x is 2. And we solve for c. So then c is going to be equal to 3 minus 14 was going to be my c. So c is going to be minus 11. Therefore, y is going to be mx plus c, which is minus 11. I've just crossed that one out there because we use this formula here, y equals mx plus c. We don't like to use that one. You can, but our preference is this one over here. Okay, and then we move on to number B to find the equation of altitude AP, which is this one here, which is at 90 degrees. So now if we want to find the equation of AP, we once again have y equals mx plus c. We need the gradient and we need a random point xy. Now our gradient is going to be easy to find because we have lines that are perpendicular to each other. So the first thing we want to do is we can find the gradient of BC, because I've got B and I've got C. So if I've got the gradient of that line, I can find the gradient of that line, because we know that the product is -1. And then I've got the gradient and I've got a random point A, which I can substitute in. And if we have a look, let's look at the method here. We're on number B. So we first find the gradient of BC. I'm going to leave you to do it. You can stop the video and you can just see how they actually work it out. Therefore, because they're perpendicular, the gradient of the altitude I'm looking for will be 2. Once again, we're going to go y equals 2x plus c, and we're going to substitute our random point 2 and 3. So that'll be 3 equals, 2 times 2 plus c. So my c is going to be 3 minus 4, which is -1. And that then is going to be number B. Then let's go up to number C. Number C, we want to find the equation of BC. And BC is going to be this line here. Okay, and that's also quite easy now, because we've already found the gradient. And then you can either substitute that point there or that point there. And we go down to C and we get the answer. Okay, they've put it in that form, but the way that we do it, we would probably end up with something like, let's just get it into standard form. So the answer that you would get would probably be something like this. Y equals minus x over 2 minus 7 over 2. Let's go to our next question. The next one is we're looking for the coordinates of P. So let's look, where's P? It's a bit messy at the moment, but P is going to be over there. So if we're looking for the coordinates of P, P is where line BC, let's see if we can use brown. It's where line PC and AP cut each other. So P would be the point of intersection between line BC and line AP. P would be the point of intersection. So remember the point of intersection, we use simultaneous equations, and we're going to go down and look and see at that one. There we go here. So P is the point of intersection of AP and BC. So we need to solve it simultaneously. Remember, we have two options. We either have elimination or we have substitution method, either method. Let's see what they've done here. They have used substitution method. And once they've used substitution method, you can go and have a look at that. You end up with P being the point of intersection -1, -3. Okay, let's go back to the last question. I'm apologizing for the untidiness of this, but as soon as I get my Apple Pencil, it will be so much better. Okay, last question, the area of triangle ABC. So we want to know the area of this full triangle here, and we know from long ago that the area of any triangle is always a half times base times perpendicular height. And if we look carefully here, because we've got that 90 degree, this is going to be my base and this is going to be my height. Base, height, perpendicular to each other. Let's go down and have a look at the solution. So we need the base and the height. So we need the length of BC, and we have our distance formula. And then we find the length of AP with our distance formula. And we know that the area is a half times base times height. So it's going to be a half times 4 root 5 times 3 root 5. And it works out beautifully to be 30 units squared. Okay, so this is a lovely example combining many different rules and facets and information that we need to know of analytical geometry. And I want to give you another few examples to do in your homework to practice this, kind of bringing it all together. So good luck, grade 11s.